Lesson 8.5, Day 1, Solving Rational Equations. The essential question, how do I solve rational equations? Please write that down. Who uses this? Kayakers can use rational equations to determine how fast a river is moving. To solve a rational equation, we're going to start by multiplying each term of the equation by the least common denominator of all of the expressions in the equation. This step eliminates the denominators of the rational expression and results in an equation that you can solve by using algebra. So let's look at example 1. We're solving the rational equation. So I'm going to do exactly what it said to do. We're going to multiply both sides by the common denominator. The only thing we see in the denominator is an x. So I'm going to multiply both the left side and the right side by x. When I multiply the left side by x, I get x squared minus 18, because this x cancels with that x, equals 3x. Now we're going to get everything on one side because I see I have an x squared. So I'm going to put this in standard form because I'm hoping that I'm able to factor this into an x and an x, a 6 and a 3. And the negative goes with the 6 and the positive goes with the 3 because they have to add to a negative 3. Now I'm going to set each factor equal to 0. And I'm going to get x is equal to 6 and x is equal to negative 3. On these, we always have to check our solution. And the only reason we have to check our solution is because we have an x in our denominator and we cannot ever divide by 0. Well, if I plug in 6 or negative 3 into the denominator here, I'm fine. All right, so there's my two answers. Example 2, I'm saving for class, and I'm going to example 3. Solve the equation. And so I'm going to actually rewrite this equation. There we go. So when I look at the denominator, I see an x and I see a 4. So we have to multiply both sides by the common denominator, which is going to be 4x. 4x. So it's like 4x over 1. So when I multiply 4x times 6 over x, the x's cancel, I get 24. When I multiply 4x times 5 over 4, the 4's cancel, and I get 5x. On the right side, when I multiply 4x times negative 7 over 4, the 4's cancel, and I get negative 7x. So my objective is I'm solving for x, so let's get the x's all on one side. So we get 24 is equal to negative 12x. Divide both sides by negative 12. 24 divided by negative 12 is negative 2. Check our solution. Go back up to the original. There's my x in the denominator. I plug negative 2 in there. I'll be just fine. Saving an example 4 for class. Down at the bottom of this page, we're talking about an extraneous solution. That is a solution of an equation derived from an original equation that is not a solution of the original equation. When you solve a rational equation, it is possible to get extraneous solutions. These values should be eliminated from the solution set. Always check your solutions by substituting them into the original equation. Let's see, are we doing example 5? Yes, we are. Okay, so again, I'm going to multiply both sides by the common denominator, which is x minus 2. It's like over 1, x minus 2. When I multiply the left side by x minus 2, the x minus 2's cancel, and I get 5x. When I multiply the right side by x minus 2, the x minus 2's cancel. I get 3x plus 4. Move the x's all on one side, and I get 2x is equal to 4. Divide both sides by 2, x is equal to 2. When I plug that 2 back in, we have a problem. If we plug 2 back into the original, we get 2 minus 2, which is 0 on both sides. You cannot divide by 0. So therefore, this is not a solution. This x equals 2 is exactly what we just talked about. That's our extraneous solution, which is a solution that is not a solution of the original equation. X equals 2 is not a solution. And so there's nothing else left in our solution set. So this is where we would write no solution. That's what an extraneous solution is. An extraneous solution is a solution where when we plug it back into the original, we end up dividing by 0. Example 6. So I'm going to multiply both sides by the common denominator, which I see is x minus 8, but also a 2. We'll go like that. 1. So when I multiply the left side by the 2x minus 8, the x minus 8's cancel, and I get 2 times 2x minus 5. Plus, when I multiply x over 2 by the 2x minus 8, the 2's cancel, and I get x minus 8. And on the right side of the equation, multiplying 11 over x minus 8 times 2x minus 8. The x minus 8's cancel, and I get 22. So now let's do some simplifying here. Distribute that. I get 4x minus 10 plus x squared minus 8x equals 22. Let's put this in standard form. X squared 4x minus 8x is a negative 4x minus 10 equals 22. I see I have an x squared, so therefore I'm going to put everything on one side. So I get x squared minus 4x minus 32 equals 0. Let's see if I can factor this. I have x, I have an x. I know that 8 times 4 is 32. The negative goes with the 8. The positive goes with the 4 because they have to add to a negative 4. And now I set each factor equal to 0. And so I get x equals 8 and x equals negative 4. Go back to the original. If I plug in 8, I'm going to be dividing by 0. If I plug in negative 4, I'm going to be fine. So this right here, the x equals 8, that is our extraneous solution. That's a solution that we find that really is not a solution. So our only solution here is negative 4. Saving that for class. Oh, what is your favorite sport to play or watch? And how many more days of school are there? These are kind of like fun little video questions.